Ganaadhipataye. Good evening. Good evening, Shravan. Good evening. Leave a message in the group, Tejal. Good evening. Yesterday only 20 people are joined out of 43. Sir, good evening. Yesterday, we left with one more case study question. Case study 3. Go through that question. A mathematics exhibition is being conducted in your school, and one of your friends making a model of factor tree. He has some difficulty and asks for your help in completing a quiz for the audience. Observe the following factor tree and answer the following question. So I am going to draw the factor tree. This is the factor tree, and we need to fill first. We need to find out x value, y value. Here is x 5 2783. This is y 253 11 and z. Children, first find out x, y, z. Fast. Find out x, y, z. First find out z. Find out z. Yeah. Z value. So how can we get Z value? Z is equal to 253 by 11. Z value 253 by 11 because 11 multiplied by Z is 253. 11 multiplied by Z is 253. 11 multiplied by Z is 253, then Z is equal to 253 by 11, which is 23. Z value 23. Okay, children. Now, how to find out Y? Again, Y into 253. Y into 253 is 2783. Then Y is equal to 2783 by 253. Y is equal to 2783 by 253. How much? Eleven. Good. So Y value 11. Now X value. X is equal to 5 into 2783. How much? 5 into 2783. So X value 13915. X value, Y value, Z value. Okay, na? Now, read the question, children. You need to give the answers for the questions over there. What is X value? 13915. What will be the Y value? 11. What will be the Z value? 23. So all the three questions are done. Fourth question. Read the fourth question. According to fundamental theorem of arithmetics, 13915 is a what type of number it is? What type of number it is? See, we can express 13915 as 5 into 11 into 5 into 11 into 253.
You are professional fellow.
253 into 23. Five into 11 into 5 into Y value 11 into 11 into Z. 2 11s, eh?
Yes.
Yeah, 2 11s. 11 into 23. 5 into 11 into 11 into 23. So it is a composite number. And the prime factorization of 13915. Prime factorization of 13915. 5 square into 5 into 11 square into 23. 5 into 11 square into 23. Option C. Okay, na? Yeah. So like this, we can observe the case study questions. And case study here, what I send it to you, all case study questions are objective type. Sometimes one word answers or 2 lines answer questions also will be there. We'll see that one afterwards. Means first, whatever the material I send it to you is from CBSE directly. Whatever the material in case studies questions, the material of this case study questions, what I send it to you in this chapter, is directly from CBSE. So CBSE provided case study questions for all the chapters. It is with me. We will discuss each and every question in each and every chapter. Now, morning I kept one worksheet on polynomials. Children, go through the questions. It is there in the group. Polynomials. A handwriting worksheet. Read the first question. Find the quadratic polynomial whose zeros are. Find the quadratic polynomial whose zeros are. How to do it? Any clue from your side? First one, -1, comma 2. We need to find out a polynomial. We need to find out a polynomial whose zeros are -1 and 2. How to do it? Any clue from your side? Try to recall. I told you one formula, a direct formula to find out the polynomial. No one answering? -1 and 2 are the zeros of a polynomial. You need to find out that particular polynomial. Only 13 are joined. Only 13 people are joined. Tejal, Amulya is not there? Yes, correct. X square minus a plus b into x plus ab. Instead of taking ab, you can take alpha beta. Instead of taking ab, you take alpha beta. X square minus alpha plus beta into x plus alpha beta. What are alpha and beta? We assign one 0 as alpha and the other 0 as beta. That's all. They are unknowns. Alpha, beta are unknowns. So this we consider -1 as alpha and -2 as beta. Now substitute the values. X square minus 1 plus 2 times x minus 1 into 2. So when we simplify this, x square minus 1x minus 2. So the polynomial is x square minus 1x minus 2. Okay na? Okay. Now see the next question, children. See the next question. Find the zeros of the quadratic polynomial and verify the relation between zeros and coefficients. I am taking 4x square minus 6x. This question. 4x square minus 6x. First, we need to find out the zeros of this polynomial. After finding the zeros, we need to verify the relation between zeros and coefficients. So, how to find out zeros? So, this polynomial is having only two terms. So, in these two terms, I can take 2x common. 2x common. 2x is common out of these two terms. So remaining is 2x minus 3. Remaining is 2x minus 3. Now 0 of 2x is 0 only. I told you polynomial of the form ax square plus bx. Polynomial of the form ax square plus bx whose zeros are 1 0 is 0 and the other 0 is minus b by a. I told you already when I am explaining this one in RSI. Polynomials of this form means where constant is not there. We can observe that in the given polynomial there is no constant term. There is no constant term. So for such polynomials, 1 0 is 0 only and the other 0 is minus b by a. So 1 0, 0 of 2x is 0 and 0 of 2x minus 3 is 3 by 2. Minus b by a, so minus of minus 3 plus 3, 3 by 2. Now we got both the zeros. We got both the zeros. Now we need to verify the relation between zeros and coefficients. Write here coefficients, zeros. So what are the coefficients? A 4, B negative 6, C 0. C constant 0. And here alpha 0, beta 3 by 2. We got two zeros na? Alpha 0, beta 3 by 2. Now find out minus b by a, c by a. And here alpha plus beta, alpha beta. Find out these values. In the coefficient side, find minus b by a, c by a. And 0 side find alpha plus beta, alpha beta. So minus b by a means minus of minus 6 by 4, which is 3 by 2. And c by a is 0 by 4, which is 0. So minus b by a we got 3 by 2, c by a we got 0. Now alpha plus beta, 0 plus 3 by 2, 3 by 2 only. Alpha beta, 0 into 3 by 2, 0. So what we can observe? Alpha plus beta is same as minus b by a, which is 3 by 2. Alpha plus beta is same as minus b by a, which is 3 by 2. And alpha beta is same as c by a, which is 0. This is the relation that we can observe for any polynomial between zeros and coefficients. This is the relation between zeros and coefficients between for any polynomial, any quadratic polynomial. Alpha plus beta is same as minus b by a, alpha beta is same as c by d. Okay, na? So like that you have to complete the problems in the second Roman. Now, everyone, so try to solve all the problems in the second Roman. Now, third problem. If 2 is a zero of p of x is equal to 4x square plus 2x minus 5a, then find a. Find a. If 2 is a zero of 2 is a zero of this polynomial, we need to find out a value. See, it is clearly given that 2 is a zero of this polynomial. What it means? What it means, children? Given 2 is a zero of p of x. What it means? Anyone? Last class I told you in the school, day before yesterday. It's alpha. No, what is the meaning of zero? I told you that. 2 is a zero given. What is the meaning of it? 2 is a zero, it is given clearly. What is the meaning of it? If we put 2 in the place of x, the value of the polynomial becomes 0. Very good. If we insert this value in the place of x, the value of polynomial becomes 0. Okay, na? When we insert this value, given 2 is a 0, given 2 is a 0 of this polynomial, so when we insert 2 in the place of x, the polynomial becomes 0. It becomes 0. Now simplify. 2 square 4 into 4, 16 plus 4 minus 5a is equal to 0. 20 minus 5a 0. 20 is equal to 5a. A is 4. A value 4. Okay, na? A very, very important model. See the fourth question. Fourth question is very, very important model for board exams. Very, very. Board exams ki chala important model. Fourth question. If 1 0 of the polynomial 2x square minus 3x plus k see, this is a quadratic polynomial. It's a quadratic polynomial, and we know that it is having 2 zeros. Is that right? And it is given 1 0 is reciprocal of the other. Find the value of k. 1 0 is reciprocal of the other. What is the meaning of it? 1 0 is reciprocal of the other. What do you mean by that? If we understand the statement properly, this statement properly, the problem is done in 2 steps. The problem is done in 2 steps. What is the meaning of this? 1 0 is reciprocal of the other. Consider alpha comma beta are zeros. Consider alpha comma beta are zeros. It is given that 1 0 is reciprocal of the other. What is the meaning of it? Alpha is 1 by beta. 1 0 is reciprocal of the other. Alpha is equal to 1 by beta. We can take like that. We know alpha beta is C by A. Relation చూసాం కదా మనం. We observe the relation between zeros and coefficients. So alpha beta is C by A. Alpha beta is C by A. Now alpha beta, insert 1 by beta into beta is equal to C is K, A is 2. C value is K, A is 2. So C by A is K by 2. Now beta get cancelled. 1 is equal to K by 2. K is equal to 2 over 1 is equal to 2. 1 is equal to K by 2. Then K is 2. Okay, na? And there is another problem of the same type. Problem number 5. If 1 0 of the polynomial is reciprocal of the other, find the value of A. There is another problem. A square plus 9x square. A square plus 9 times of x square plus 13x plus 6a. Same. For this problem also 1 0 is reciprocal of the other. And here also alpha beta C by A. Given alpha is 1 by beta. That means 1 is equal to C by A. C 6A. A square plus 9. C value 6A. A value A square plus 9. For problem number 5 also same. 1 0 is reciprocal of the other. Now from this what we can do? A square plus 9 is equal to 6a. A square minus 6a plus 9 is equal to 0. A square minus 6a plus 9 is equal to 0. We can move this one to this side. We need to move it. Now children, you can observe here, this polynomial is a perfect square. This polynomial is a perfect square. We can write this one as a minus 3 whole square. Observe it. We can write this one as a minus 3 whole square. A square minus 2ab plus b square. A square minus 2ab plus b square. b is 3. So this is a perfect square. A minus 3 whole square. Then what is A? A minus 3 is 0. A is 3. A is 3. Okay, na? So that's all for today. Again, we will meet on Monday. Monday we will go ahead with the case studies questions in polynomials. Monday we will go ahead with case study questions in polynomials. Okay, children. Mahaganadhipataye Namaha. Thank you very much. Dhanyavad. Thank you very much.